Hey everybody, welcome back to the saw shop. It's actually Monday morning, so I'll probably post this Monday afternoon, Monday evening. I'm actually, friends, I don't usually do this, but I took a week off work and I want to spend some time with the family and just decompress. So that's what we're going to be doing this week. I got content planned, but we're going to do a few things that we haven't done on the channel this week. Anyhow, jumping back into the Ultimate Firewood, Ultimate Old Guy Saw. I ran into a little bit of a hiccup with this saw. Not a hiccup, but I'll just have to order some more parts. Remember when I took the saw apart, and actually I'll leave this top end on. When I took the saw apart, I mentioned that the gasket had swollen. Friends, I don't know if you can see, but I'm dripping sweat. It's been hot here this summer. Once the warm finally did kick in, it's been hot and muggy, and it's been hard to work in the shop. I don't have air conditioning in this shop. Maybe one day I will put air in, but it is what it is. So anyhow, this saw right now, I bolted the top end on. Now, what we're going to do here, I am going to simplify this. I'm going to make this is going to be the port job for somebody that's kind of afraid to wreck their cylinder and wants some more performance, but doesn't want to really get in and grind like you guys see us doing all the time, you know, us on YouTube that port saws. So what I'm going to do here, friends, I read through your guys' comments again on what you guys wanted to see, and a lot of you wanted to see something that you can create easily. So first things first, I'm going to have to order a base gasket or 2 or 3 for this saw. I don't have another one, and I don't have the right thickness material to make one, so I'll put in an order and order a new base gasket. So where does that leave us porting wise? Because if you don't have a base gasket, well, you can't really do your porting because you end up with the wrong timing numbers. Sorry, friends, I'm dripping here. So that's not really a problem in this case because I'm not raising the exhaust port. I'm going to widen it a little bit if it will allow me, and I'm going to show you guys how to check that out. Intake timing, I'm going to grind the intake, but here's the thing, friends. I don't have to grind the cylinder. I can actually grind the piston. So on this job, we're going to grind the piston instead of the cylinder. And all I'm doing is reshaping and flowing the lower transfers. We're not even going to touch the upper transfers. So in this case, I don't need to retime this saw until I put it back together with a base gasket. So what I did today, I have this little scratch awl that's sharp. First thing I did, I put the cylinder back on the saw, and I timed it so that the piston where it's opening, and then I took this scratch awl and I went in the corner of the exhaust port on each side and made a little line on the piston. That way I can measure how much overlap do I have. Now, if you're just starting porting, remember, if you don't have enough overlap, okay, on the sides of any port, that port can leak, either on the way up or the way down. So I want to leave probably 100 thousandths on the side of my exhaust port. So if it's 250 thousandths or a quarter inch, I could grind 150 thousandths wider on my exhaust port, get it to flow a little bit better, and still not worry about leakage. Otherwise, if you go too far, friends, you can get some blow-by. When the piston's on the way down, it's compressing the crankcase, that air and fuel that you've just pulled in on the upstroke, it's compressing it down. You can actually get some blow-by on your exhaust port. So also on the way up, you could, in theory, get a little bit of blow-by when you're compressing it. So you don't want to do that. Now, how am I gonna port the piston without timing it? Well, that's simple, friends. Remember in the last video when we timed this saw, I said I'm going to add like 10 degrees of total opening. Well, 10 degrees of total opening is 5 degrees sooner and 5 degrees later that the piston will open and close. So what did I do? I took my assembly here. It doesn't even have to be zeroed. I timed where the piston opens, held it with my finger, and then I took my wheel, okay, held it with my finger, took my wheel and moved it 5 degrees down, okay? So my piston's here at the bottom of the intake. I moved the piston down 5 degrees, okay? I took my little scribe here and I made a little line, okay? If I grind the piston to that line and shape it, 5 degrees sooner opening is 10 degrees total timing, okay? Total duration. So there you go. I now have my 10 degrees. In fact, friends, we don't have to time this saw anymore, okay? I'm running a base gasket because my squish is too tight. So now, because we haven't raised our exhaust, base gaskets are pretty similar in height, and we know no matter what, the 5 degrees we're adding will be 10 degrees timing. We don't have to time this saw anymore. I can just throw it back together and not worry about my timing, okay? Again, we're not building a race saw here. We're building the ultimate firewood saw. We are adding some performance, okay, without going crazy. Kind of like a diesel truck, friends. My pulling rig, okay, my 7.3 Power Stroke. Yeah, I could add an intercooler, bigger injectors to that, a bigger turbo. I could do all kinds of things to that thing, okay? But if I add a bigger turbo and bigger injectors, I'm going to make more heat when I'm pulling. And if I make more heat when I'm pulling, I'm probably going to want to put an intercooler on and. So what I choose to do, friends, is I chose on my pulling rig, I put a full 4-inch exhaust on it. You guys saw that in a previous video I did a long time ago. To get the heat down, it allows the turbo to spool up a little bit sooner. It makes a little bit more boost now just because everything's not clogged up. And it makes it a better towing rig. It's also better on fuel. Now, will it pull with a guy that has the same truck as me and put bigger injectors, a bigger turbo, intercooler? No, it definitely won't. But I've added a noticeable step in performance to my truck, and it tows and just drives better. So that's what we're going for in this setup. Okay, I've pulled the top end off, unbolted it. I'm going to bring you guys in close. Let's have a look at the marks I put on the piston. Let's measure them, and then we can grind on this piston. Let's do some piston work today, and then in the next video we'll finish up by doing a little bit of cylinder work, and that's that. I'll bring you guys in, and let's take a look. Okay, here's our piston. I put some black on it. You can see this line going up and down. Okay. I made a line here, and I just took my calipers here, and I made a little line, just so I could see what's going on. So 185.5 thousandths is what we're dealing with, okay? So that's how wide the exhaust port is. So I said I don't want to go past like 100 thousandths, 110. We don't have to make this too crazy. Oh, sorry, friends. Hiccup. Too crazy, but okay. So that's about how far we can widen it. Right there and right here. Okay. Now, how do you figure that out? Well, I'm just going to eyeball it, but take a straight edge. And really, friends, you can see your piston skirt right here. Okay, right here. That's where your piston skirt rubs. Okay, so all we measured, focus, there we go. All we measured is the distance between here and there, okay? This line here, from here to there. Okay, now I don't want to widen that much, but in this case, because I can see this line clear as day, I'm going to eyeball this and just go in the corners and go zing, zing, and just widen them a hair. Again, I don't want to go too far. Okay, now the other side of the piston, you guys should be able to see this line right there. See that line there? So at this point in the stroke, and remember, it's not linear, the piston speed changes based on where it's at in the stroke. What changes that? A lot of things, but where the pin is on the crankshaft, your stroke, all that stuff changes this. So this isn't linear on every saw. Okay. So we're like 70 thousandths, somewhere around there. Okay, I'm just gonna. So we'll say it's 70 thousandths. Okay. So I'm gonna pause you guys here. Let's do some math. 5 degrees is 70 thousandths. Well, that's a pretty. If 10 thousandths was 1 degree, right? 5 degrees would be 50 thousandths, but it's 70 in this case. So 1 degree is about 12 thousandths. No, 14 thousandths, friends. Okay. So 14 thousandths, 14 times 5 is 70. So 14 thousandths is 1 degree in this saw. So if I take this, reshape it, and grind it from here to here, okay, I'll end up with intake timing that's longer. Now, remember, you can cut the whole bottom off if you want, friends. Really, you could go and cut this whole thing off. I don't like doing that. This piston's top heavy. By top heavy, I mean the distance from here to here, okay, here to there, is substantially greater than the distance from here to here. It's top heavy, so it already wants to do this. The only thing that's keeping it from rocking is its fit in the bore and the skirts. Now, these skirts are already super short, okay? By making them shorter, you're just creating a scenario where this thing can rock more. And you have the same amount of thrust on less surface, meaning your pressure, your thrust on the surface per inch or whatever you want to call it is actually going to be more, which means you'll wear your piston out faster. Again, ultimate old man saw. A firewood saw is not a heavy use saw, but we want these things to last as long as possible. So what I'm going to do here, this is very simple. This is old school porting, friends. Okay. I'm just going to go in. I'm going to take my marker and kind of show you guys what I want to do. Okay. Something like that. Okay. I'll literally go in and just cut a half circle kind of arrangement right there. I got a little scratch on the piston. I'm not worried about that. It happens, friends. Okay. I'm going to cut a half circle in the piston about that shape. Then I'm going to go in and I'm going to open up these windows. And I'm going to do something different on these ones so you guys can kind of... these are half blocked. Now, I don't want to widen the transfers on this because remember, I'm doing this in a way that you guys can create easily. The widening transfers is difficult, friends, because like I said, you can chip it, you can come out of the transfer. Okay, these are like this. They're half covered by the lower transfers. What if we cut the inside to point this way so that the air is coming out of these windows and feeding right into the transfers instead of going this way and hitting the cylinder? Well, if you look, they're cut straight. Why can't we go in here and cut this corner out within reason? And again, we can lengthen these a little bit higher, up and down. We can go in here and grind a little bit out. Again, depending on how brave you are. Remember, you take too much off this, and you can break the top of the piston off. You can break the bottom off. Just be careful. Okay, friends, I'm going to get my grinder set up, grab some tooling, and I'm going to grind this piston right now. So right now, we're lightening this piston, and we're not touching the exhaust port right now, but you measure the piston to get your exhaust port width. I'm going to grind this. I'm going to cut all the corners so they're not sharp. I'm going to take these casting marks off. I'm going to go in and smooth the back sides here, right here, and right there. Okay, I'll hit you guys back up when we have everything done. So again, take a look at these windows. The back here. Inside. Okay, take a good look at these windows. I'll be right back. Oh, and while we're at it, I'm going to zero this. Let's weigh this piston. 49. This is not the most accurate scale. We'll say it's 49. I might only get a gram off of this piston, but we're going to find out. And here's our piston completed. I'll turn your guys' light on. 1 measly gram. There's a small pile of dust on the bench top. 1 gram, friends. That's what we took off this piston. She ought to be a real hot rod now. Okay, turn this off. And I'll bring you guys in. It's not about hogging out material. It's about where you take material out. Okay. So, first thing I did, I went in with my tooling and cut these a little bit wider. That seems to be what I do to steels, and it seems to work. Okay, that way the air can flow a little bit better on the inside of the transfer, because remember, these are blocked like this. Okay. That's what Stihl does. It works, but we can make it a little bit better, can't we? Okay, the main thing I did, I took my tooling in here. These stock were like this. So the air is going to flow right in, and it's going to hit that spot where it's covered. I took this, and I cut it on an angle. So now, the air goes through, hits the wall, or comes through, and it is tapered, and it is pushed in this way. Okay? And see this one here, pushed in this way, which should help fill these transfers a little bit better. Okay? Did both sides like that. Again, cut it in this way. I'm putting this file on an angle that I ground them at. Okay, whereas before they were like this. Okay, there's a bunch of material in here. Now, if you're afraid to do this, I understand. If you do it wrong, you will blow up your saw. So this isn't high level stuff. You just gotta have your high level brain on the day you do it. If you're not having the sharpest day, probably don't grind on your piston. I certainly don't. Main thing is, don't cut these too much or at all. As you can see, I just went in and just kissed the bottom here and here. Okay, don't cut these out too much. Don't cut too much out of here, because this supports. There's a tremendous amount of force on the wrist pin as this is going up and down, right? As it changes directions. The only thing holding the rest of this piston to the crankshaft is these webs of metal, okay? So this is, in my opinion, this is your main support here, but don't forget the piston's wanting to do this, and this keeps this from, you know, rattling off. So don't cut too much out of here. You can cut more than I did, but again, I'm going for a little bit more performance and longevity. Okay. Same thing on this side. Just went on the bottom and just, okay. Don't want to cut too much out. Went in here and smoothed this out where I saw it or thought it to be appropriate. Notice I beveled all the edges. Okay. There's no sharp edges. Just went in here. Everything's radiused. When you go down in here, everything's radiused. Okay. I cut the inside off these casting marks. Okay. Everything's been radiused in here. When you go and grind in, you'll have a ledge here. Go in with something round, or I did this with a polishing wheel or a sanding drum, you know, these things. Go in there. I actually leave them off the end of the drum a little bit so that they'll bend and conform to what you're grinding. I just went in here and filed these down. I broke this edge and this edge. Okay. Trying to get rid of any sharp corners. There is a slight radius on these now. Radiused the inside and the outside. Okay. All the way around. Can you see the radius there? Let's see if we can get this to focus. There we go. Okay, I've radiused. You can see the light catching. That right there is my radius. Get rid of the sharp edges. It'll keep your piston happier for longer. Get rid of stress risers. Get rid of the pistons wanting us to crack. Now, if you look, I got to go in and shape this a little bit more. Okay. Right here, I'm just going to hit this corner. I'm trying to make this as symmetrical as possible, but there's my intake timing. Okay, and all I did, I scribed a line here and here, one in the center, and one for my height, and I just went in and did it. Now I'm going to go in and finish this, and I'll show you guys. Okay, that's pretty symmetrical. Edges are radius. Again, I've cut these corners around, all the way around. Well, it's this side, it's radiused. And I've gone around and broke all the edges. Feel the piston. Use your thumb, use your finger, and just go in there and feel for any sharp spots. I feel 0. And again, there's our intake timing. Okay. So now, when our piston is traveling up, I'll get this to focus here. It will open like that. Okay. Okay, so instead of it opening here, okay, instead of it opening like here, it opens here. Okay. I'm having trouble getting this to focus today here. There you go. Okay. So instead of it opens here now, instead of like right here. Okay. So it opens earlier and it closes later. Old school. This is how they used to do back in the day. And this does work. Believe it or not. And if you really want, you can cut your exhaust timing into the crown of the piston. You can cut your transfer timing into the sides of the piston. You guys have seen it. That iron horse saw that I own, my 372, all the timing is done on the piston. Nothing more, nothing less. And there's lower transfer work and work done to the piston. And that saw runs like a scalded cat. So go figure. Okay, well, I hope you guys are enjoying this one. This has been a fun build so far. I'll order what parts I need. And next time you see this, we'll do some grinding on the cylinder. We'll be in and out of that cylinder in about 20 minutes probably. What did I use? Various sanding drums, you know, large and medium. This Fordham bit, Fordham tool, a scribe, and what else did I use? A pair of calipers. You know, nothing fancy. And most people should have this stuff laying around. And again, you don't need a Fordham. You can do this same build with a Dremel. And Dremels, you can buy them cheap now. I ported a lot of saws with my no-name Dremel back in the day. But anyways, friends, what I'm trying to show you here is 70% of the gains can be had in 30% of the work. The other 30%, you know, when you see us building monster saws on various channels, you see it all over the internet, that last 30% of the gains is 70% of the work. So with this type of technique, you can build a really strong saw without having a ton of time invested into it. And when you're done, you'll see this is going to be a good running saw. I guarantee it. And you guys will see with this one that you can build a really strong saw without doing a ton of crazy work to it. And this one will show it. Anyhow, thanks for watching. Take her easy. I'll see you guys in a couple days. Later.